Okay, some people have forgotten how to simplify radicals, so I'm just going to give you a little reminder here. But remember, if you have a radical, and just a second, let me get my pen here. So usually if it's something nice, like the square root of 25, we can just get a 5 out of there because 25 has a square root, so once we do the square root, the symbol's gone. Same thing, you know, square root of 16, we just get 4 and so forth. But sometimes you get numbers that don't have a nice square root. So for example, you get something like the square root of 10. Now, a lot of times we'll change it to a decimal, but in trig and other classes, we like to keep it a radical. So the factors of 10 are just 2 and 5. Neither one of those have a square root, so square root of 10 is the best answer that we could leave it in an exact form. But some things have factors where they do square root, and so we want to take them out. So for example, if I give you the square root of, say, 20. All right, 20 by itself doesn't have a square root. It ends up being a decimal. But if I look at the factors of 20, I can recognize that 4 is a factor of 20, but it does have a square root. And so what I can do is I can focus on this part right here, excuse me, and square root that, but this is stuck because it doesn't have a square root. So you get 2 radical 5. And, excuse me. And again, the reason is because the square root of 4 has an answer that, so once you do the math, the square root symbol's gone and the answer is 2. But the square root of 5 is stuck. I can't do anything with it. So this, I can square root and get a 2. This is stuck, and so that's why that's my final answer. So another example is you might have square root of 75. Again, you could do it on your calculator and get an approximation, but in a lot of math classes we like exact answers. So instead, you want to look for factors that have square roots. So this has 25 times 3. And again, so I can break this into 2 pieces, the part of each factor. This part is going to be able to get out of the radical because it has a square root. The answer is 5. The other part here is stuck because 3 does not have a square root. Another example might be something like the square root of 343. Okay, and again, that might be not anything that you're familiar with, but again, you might try dividing this by perfect squares. Some people like to do that, like divide it by 4, divide it by 9, divide by 25, 36, things like that. So 5 times 5, 6 times 6, 7 times 7, and so forth. Some people like to divide by prime numbers because they kind of notice that a pattern here. So they try dividing by, 2, 3, 5, 7, 11, things like that. So whichever way you go, if you divide by 7, you're going to figure out that this is 7 times 49. If you divide by perfect squares, trying to look for a perfect square, you'll realize that 49 does go into this. All right, so at this point, I can square root both of these separately. The problem is this one doesn't simplify. 7 will give you decimal. It's a prime number. There's no factors that are going to break down that have square roots. But on the other hand, this one does. So that one actually equals 7. So my final answer is 7 radical 7. Again, this is just a quick review, but I hope it helped you.